So yesterday we talked about central angles, semi-arcs, all of those other things. And today we're going to talk about a different kind of angle, which is kind of cool and funky. Here we go. And it's called inscribed angles. Okay, so we have something called inscribed angles. Now, one of the terms we learned about yesterday was a chord. And if you remember, a chord was formed by um, two endpoints that would meet on a circle. So a chord would be, that's considered a chord, that's a chord. If you recall, the longest chord is supposed to go through the center as a diameter. Those are the things here. So an inscribed angle is formed by the intersection of two chords. So if I say DOG, angle DOG is an inscribed angle. Okay? It's an inscribed angle. I'm sorry, my handwriting is so bad. This pen is very interesting. Okay, so angle DOG is an inscribed angle because it's formed by DO, by chords. I'm going to even say by chords DO and OG. Okay, so an inscribed angle is formed by the chords, and the vertex will always sit on the circle. So the vertex of your angle will always sit on the circle, okay? All right, it'll always sit on the circle. So again, I'm going to go to a new guy. So if I have this beautiful guy right here, that's a terrible circle, but let's get over ourselves, okay? I could probably look up shapes and draw shapes in here, but I'm so lazy. Okay, so if I say fun, right, FUN is considered an inscribed angle, okay? If I have, ooh, she's getting crazy, she's getting crazy. So if I say soup. Do you see two inscribed angles, my friends? Hit pause right now and see if you can figure out which ones they are. Again, remember, an inscribed angle is formed by two chords, and the vertex sits on the circle. So if you hit pause and come back to me, hit pause. You'll notice that SOU, that angle SOU, is an inscribed angle, and, which is this guy right here, an angle OUP is also an inscribed angle. So now, moving on to the next thing, yesterday we had the idea, right, that if we have a central angle, and I say that that's 40 degrees, right, that it is the same exact measure as its arc. So if I put PU, you smell, and let's say, for example, I want to go ahead and draw in this chord right over here. I don't like how I drew that. Okay, you know what I'm going to do? You know what? No, I'm not. Okay. I'm just going to run with this, and I'm going to erase this little messiness here. Okay. Why? Because I have OCD and it's good for me. All right. Okay. Come on. Boom. All right. So that's going to be, that's 40 degrees. And then if I take, because I'm doing this free-handed, which bothers me, we can go ahead and fill out the other things that we need to fill out. So, and if I PSU, so this is supposed to be an inscribed angle because the vertex is sitting on the center. So the first thing I want you guys to recognize that, first of all, we're going to call that circle X, so that's a center point. So that means SU is a, hope you said diameter, good for you. And that XP, XU, SX are called, you got it, they're called radii. So in your world, you should go ahead and mark all of your radii congruent. And you should also recognize that SXP is an isosceles triangle, making this guy congruent to that guy. So we have two equal angles because we have an isosceles triangle. And then we should also note that this angle right here is supplementary to this one. So this is going to be 140 degrees. And then there's 40 degrees left over to split two ways. So this is going to be 20 degrees. And then this is going to be 20 degrees. Now what I want you to notice is that if I highlight my inscribed angle, it intersects this arc that we're going to call PU, okay? So we say angle SPU intercepts arc PU. And if you notice not only does PXU intercept that arc, but this inscribed angle also intercepts that arc. But if you look over here, the central angle and its arc are equal. But the arc and the inscribed angle, what do you see is that relationship? So if this is the arc, it looks like the angle is, you guessed it, it's half. So let's see if that works for other examples, okay? So again, if I start here, and I start at my center, and I go down here like this, and let's say that this is 80 degrees, all right? And let's make this 100 degrees because we know it's 100 degrees. And let's go ahead and redo that because I don't like what I just did. I'm trying to do things on the fly and it's not good for me. I just want you guys to see that the relationship between an inscribed angle and its arc is that the angle will always wind up being half the arc. So let's go and see if we can find a new pretty example as you process that. So again, to keep this nice and simple, we'll go this way this time. We'll go over here. So again, I'm going to change this. Let's go to yellow because yellow is fun. Y-E-L-P, Yelp. I'm going to give it 2 stars because you didn't bring me my glass of water even though the food was delicious. Anyhow, so again, this is circle L. And you're probably saying, what is she talking about? She's nuts. I know. Let's make this 50 degrees right here, okay? And again, circle L, so therefore this is a diameter. EL is a radius, so is LP, so is YL. So what did you do? Oh, yes, you did. You marked all of those segments equal to each other. Bravo, because they should be. And again, there's that isosceles triangle we were talking about. So that means that this is going to be 130 degrees, and there's 50 degrees left over. So we're going to go 25 for this guy and 25 for that guy. So again, here's my central angle. Here's my arc, EY. That intercepts that. That's going to be 50 degrees, but let's take a look at the inscribed angle because the inscribed angle is YPE, and YPE looks like it's half of 50. So nice thing that we know is that an inscribed angle is always 1/2 of its intercepted arc. Okay, so with that said, let's go and do some examples. Okay, so let's take a look over here at the first one. Now I have some legit stuff going on here. So this is my inscribed angle because as you can see, it's formed by this chord and by this chord, and it's intercepting arc that's 128 degrees. And so therefore this angle should be, you guessed it, half of it. So whatever half of 128 is, if you guess 64 degrees, you are 100% correct. Okay? Now, there are some interesting things that I would like to allude you to. You're going to have to fill some things out as you go along. I'm going to go with a new pink thing over here. So if you look at this, one of the most important things to notice is that if you see what this is, do you all see what that is? Good for you. Yes, this is a diameter, so therefore this is a, yes, that is a semi-arc. And what is the measure of a semi-arc? If you said 180 degrees, that's wonderful. And that means that if this is a semi-arc, then this whole thing here going all the way around here is also a semi-arc. So therefore, this arc plus this arc right here is going to be 180 degrees. So if I do 180 minus 66, and you guys can help me with that, 180 minus 66, you're going to get, you guessed it, 114. So that's 114 degrees, but as you can tell, A is an inscribed angle. So this again is your inscribed angle, so it's going to be half of that intercepted arc, which is this guy right here. And have you never noticed that it looks like a little ice cream cone? Like this is the ice cream and that your inscribed angle is like the cone. So that's how you kind of want to look at it. So half of that is going to be, you're correct, that this is going to be 57 degrees. Okay? Now, let's move on to number 3. If you want to hit pause, because I'm telling you that the measure of arc, BAC, is 260 degrees, and find the measure of angle ABC. First of all, ABC, as you guys should know, is indeed an inscribed angle, okay? So you know that it's going to be half of arc AC. So that's one we already know is that this is already going to be equal to 1/2 of arc AC. Because again, it's going out, creating the ice cream scoop, so it's going to be half. But if you want to hit pause and try this on your own, you know that would be spectacular. So for me, if I say BAC, B going around to A and all the way around to C is 260. So it's telling me that all of that is 260 degrees, right? Now, one thing that I do know is that this segment AB is a what? That's right, it's a diameter, which means the measure of this arc is going to be 180 degrees from here to here, which leaves us 80 degrees left over for arc AC, which means angle ABC is, ding, 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 you guessed it, 40 degrees. So bravo for those of you who did figure that out. If you look at number 4 is super interesting because number 4, you're actually given the, say, inscribed angle. Get used to making those using your definitions. Now, what do you notice about the two chords? You see how they're marked? They're marked congruent, so that means the length of this and the length of this are the same. Now, if this is 30 degrees, that means his intercepted arc must be, that's correct, 60 degrees. So now let me ask you a question. If this is my chord and this is my arc here, and if this chord is equal to this chord, doesn't it make sense that this arc, or the measure of that arc, is going to equal the measure of that arc? The answer is correct. So therefore, when two chords are congruent, the measures of their arcs are congruent. Okay? All right? So now, let's go find out what the measures of these two arcs are. So my thing is here's 60 degrees, and how many degrees are in a circle? If you said 360, bravo. So if you do 360 and you subtract that 60 degree arc, you get 300. So that means the rest of this whole thing, all of this, all the way around is 300. So therefore, from here to here is going to be 150 degrees. So y is 150 degrees. Okay? Let's try another one. If you want to, hit pause and see if you can actually find the answers to these things. I think that's one of the best ways to go and approach stuff is by saying, hey, can I figure this out? But before you go, you'll notice over here that this says that this is circle X. So the center is right there, okay? So that means then that AEC is not a central angle. It is not. So if this is 118, that is not 118 because it has to come from the center. So that's a thing to think about as you're doing this. But these problems are going to keep getting a little more complicated as we go along. So what I want to do first is I want to see, you see how I have this arc here is 118 degrees. So I'm looking at that arc. So I go ahead and I highlight my two endpoints, and then I'm going to follow the chord down and follow the chord down. And you'll notice, I don't like how I drew that. So of course I have to get my little eraser because it's a little sloppy. So I'm going to take this, so I'm going to take this and I'm going to go back to my marker. And this right here, this arc AC intercepts angle ABC, which means angle ABC must be how much of arc 118? And the answer is yes, it is half. So this should be 59 degrees. Now, before I go on, does arc AC intercept another inscribed angle? Go and take a look. Hit pause and go and see if it does intercept. So arc AC, so besides going to this angle over here, which is angle ABC, can I take my endpoints and go in a different direction? And if you hit pause, you would show that yes, it also goes down to this angle here. So we can say that arc AC intercepts inscribed angles, angle ABC and angle ADC. Now, so since it intercepts both arcs, since that arc intercepts both angles, that means both angles must be, you guessed it, 59 degrees. So here, AC intercepts inscribed angles ABC, and therefore, the two angles are equal. Okay, so that's the first thing. So we looked at arc AC and we're like, okay, that's 118, and we found the two inscribed angles. If you notice, oh look, there's another arc over here that is 66 degrees. Again, can you go ahead and find out what inscribed angle that intercepts? So again, you're going to take your 2 points, point here, and travel along your chords to see what angle it intercepts. So we can say that CD intercepts what angle? If you want to hit pause and look, go ahead and do that. If you did pause and then you turned it back on, you are correct if you said angle CAD. So that means that this is going to be 33 degrees right here because it's going to be half of 66. So now, what we can go ahead and do here is see what we can find thereafter. So, that's 33, that's 59. Do you see something else here? Ah, yes, I do. Okay, so something clever, because I was like, well, where do we go from here? Because I'm with you. I'm like, where do you go from here? Once you look at your arcs, right? You look at your arcs, the next thing you should always look for is there a diameter in the figure? Is there a diameter in the figure? And remember, this is circle X. So who is going to be your diameter in a figure? And if you said, oh, BC is my diameter, bravo. So that means that if this is 118, then this has to be 180 minus 118. And 180 minus 118, oops, not 1180, is 62 degrees. So arc AB is 62 degrees. So now we're going to take a look at this and we're going to say, okay, this is my arc. Can I find an inscribed angle that intercepts arc AB? And yes, we can. So arc AB is being intercepted by this angle right here. Let me use a different color. I'm going to go black. This angle here, angle ACB. So it intercepts angle ACB. So this angle is going to be 31 degrees right there. And then finally over here, if you look over here, if I asked you guys, can you tell me what that measure of arc BD is? The answer is yes, and there's several ways you could have done it. Number one, you have this beautiful diameter. So 66 minus 180 is going to give you, or 180 minus 66 is going to give you that arc, which is 114. So this arc is 114 degrees. Or you could have done the sum of all your arcs has to be 360. And then arc BD is being intercepted by what angle? Or what angle, or that, how do I say this? Yeah, what angle intercepts arc BD? That's what you want to find out. What angle intercepts arc BD? And if you said, hey, it's going to be angle BCD, bravo. So that means that this angle right over here, I have to erase some of this because it's really starting to get messy and icky and kooky and all that. So that right there. So this is going to be 114. So again, I'm just going to go back to my black pen just so we can actually see the angle highlighted. This angle here is going to be half of that arc, and half of 114, my friends, is going to be 57 degrees. So now you were asked to find the measure of angle ABC, which we found at the beginning, which was 59 degrees. But what I want to show you is I asked you to find the measure of angle BED. So if you look at angle BED, look over here, you can go ahead and find it by finding this angle here, and that's the guy vertical to it, or you can find this angle here using this triangle and do the angle supplementary to it. So I'm just going to do 33 plus 31, right? 33 plus 31 minus 180 is 116. So this is going to be 116, and this is going to be vertical to it, and it is going to be 116. So this is equal to 116 degrees. Now, what I want to allude you to is notice that, let me just make this prettier, that this is 116 degrees. What I want you to notice is, see the measure of this angle is 116. So it's showing you that it's not a central angle, because if it was, then this would have to be 118, but it's not, it's 116. So this is where we're using inscribed angles and diameters to help us do what we need to do. So let's go take a look at this one over here. We'll finish off with this, and then you guys can go try problems on your own, and then maybe we'll do like a meet and greet study session after like 12 o'clock on Wednesday, okay? So beginning with this, again, you started off with your given arcs, and if you look at this, are there any diameters in the figure? And the answer should be no, because it should be going through, that's the center of the circle, and it just misses going through, which means it doesn't go through, which means this is not a diameter, it's just an ordinary chord, okay? But you're trying to find out what C is, and we don't know, so it's not a central angle because that angle does not come from the center, it's just kind of lollying off to the side. So what you want to do is, again, go turn to your arcs, and based on the look of your arcs, you want to see if you can find an inscribed angle and fill out your angles accordingly. So for me, I'm looking at the 84 degrees. That's the first one that's coming to my mind, and that's 84 degrees right there. And I'm like, okay. And then again, you're going to create the chord. You're going to create the angle. There's one of my inscribed angles. So I know that this is going to be 42 degrees because again, it's going to be half. And then yet again, whoa, looky, looky here. There's a second one that is also 42 degrees, right? So that takes care of that one because they both intercept the same arc. Remember, you're taking it, you're going up, and there's your pretty little arc. And now you want to go ahead and take a look at your 100 degrees. And if I'm staring at my 100 degrees, right, go here, you can go this away, you can go this away. So this is going to be 50 degrees. Can you find the other angle that's going to be 50 degrees? You bet, if you set it right over here. So now if I want to find out what C is, I just know the sum of the angles of a triangle is 180. This gives me 92, so this is going to be 88 degrees. So a couple of things to think about. A couple of things to think about is going back over here. An inscribed angle is formed by two chords, and it's always going to be where you have the convergence of two chords, and it's always going to sit on the circle, and it's always going to intercept an arc, and there's your little ice cream cone. So again, I'm going to go back to that's your little ice cream cone. I can't get away from that. So here's your cone, right? And then there's your ice cream. So, and then this is always going to be, so if this is 30 degrees, his little friend over here is going to be 60 degrees. That's the thing to think about. And again, you should be able to name your inscribed angles. If I give you angles, you should go out to see if you can find the arcs. If I give you the arcs, you should be able to find the angles. So if I told you that this was 90 degrees, you should be able to tell me that that's 45 degrees, right? If I tell you that this is 61 degrees, you should be able to tell me that this is 122 degrees. And those are nice things to think about, okay? And as these diagrams, because that was a pretty complicated, I'll go back to that one in a second. But again, if you want to, go back to where these are blank at the very beginning of the video and see if you can work through those yourself, including this one over here, okay? So with that said, I will definitely have times where we'll be able to meet, but I hope this is helpful.